Hey! As software developers, Eric and I know how important it is to take some time to experiment, study new arguments, or make something just for fun. And that's for all these three reasons that in this video we create TronnorT, a tiny multiplayer mobile video game.
Our idea takes inspiration from a StarCraft 2 fan-made mode called Photon Cycle, which I enjoyed playing with my friends some years ago. But of course, the concept is taken from Tron, the movie. The goal is simple: drive a spaceship that generates an energy wall that can destroy opponents. All you need to do is try to cut them off, and don't crash yourself. In this video, we are going to see an overview of the development process with a special focus on the procedurally generated energy wall mechanic. Let's start with the art. We want to take inspiration from the 80s, and in particular from synthwave visuals. A mix of neon lights, pixel art and vibrant colors like violet and blue. To achieve this style, our playground can't be anything else than a grid of flashing lights. So we add 4 walls and a floor, and we create a custom shader for generating a grid. With few positional calculations on each vertex of our mesh, we understand if we need to color it with what we choose to be the grid color or the outer color. Also, we color differently a part of our grid lines, and we change the position of the colored part gradually over time, obtaining a circuit of lights. But I said that we wanted flashy lights, so where is the bloom effect? Bloom solves always everything. Now, with our playground in place, we can concentrate on our spaceship. We open Blender and start modeling. We create something simple and with a big exhaust that will be the emitter of the spaceship's weapon. The result is pretty decent, but I think something is missing. There is a steering wheel but no driver. Shame! Fortunately, this is an easy fix. Natty, I choose you! Talking about VFX, we need 2 of them. One for the movement and one for the explosion. Here, the new graphic tablet comes in handy. Eric bought it primarily to paint the texture of the VFX. He started to study them seriously, and I'm really curious about what he will achieve. The movement VFX is composed of a spiral and many emitters. My favorite is the bits emitter. The death particle instead is more complex. It has a dedicated script that handles some phases. On collision, the spaceship changes gradually to a very flashy color, giving the impression of overheating. Then we hide the game object and we place some particles. One emits many cubes, giving the idea that the spaceship disintegrates in many 8-bit style pieces. I really like them. Let's now give life to our spaceship by adding a third-person camera and the movement logic. The camera is controlled by a script attached to the player. Normally, this is an unusual setup, but not when creating a multiplayer game. In a client-server architecture, you share a scene and its game objects with many other player instances. And so it's vital that only the interested player, in other words, our player instance in the room, has control over it in our session, or the camera could end following another player. This is why when creating multiplayer games you need to specify who has control over certain game object, and you fill your code with checks like has authority or is mine. You want to run the code only and only if the player is yours. In this case, we want the camera to follow only our player and not the other players that will connect in our session. Multiplayer is a wide topic, we will not deepen it in this video. But if you are interested, we can do another TronnorT video showing how we have implemented it. The camera always keeps the same distance offset from the player and uses the look at method for the orientation, keeping the focus on the player transform. The only particular thing is that when steering, we add an offset to the look at point, seeing more level space on the left or on the right. This version of the game is mobile, So we add a virtual joystick to control the steering. I say only the steering because once the game starts, you can't brake or accelerate. The spaceship moves at a constant velocity. To move and rotate, we use the Rigid Bodies API. So we use the move position function to change the position constantly over time and the move rotation to rotate. While steering, we also rotate the spaceship mesh. Our spaceship is ready to go, but it's harmless. We want to destroy our opponents with the energy wall.
Lemmy smash.
But how can we generate it at runtime? We usually have our 3D objects already inside the scene or in our folders. Remember that the shape of a 3D object is defined by its mesh. And a mesh is a collection of points, called vertices. It is how we place these vertices in the 3D space and how we connect them that lets us draw shapes. The invisible line between two vertices is an edge, and when we connect three vertices, we obtain a triangle. Depending on the software, complex 3D shapes are always a union of simple ones, generally triangles or quads. The 3D world in Unity works with triangles. Now we know that we need vertices to build our energy wall, but where do we store them? Simple, in the mesh filter and mesh renderer components. The mesh filter stores the mesh data of a model, while the mesh filter uses this data in combination with a material to render the object in the scene. So, let's start from simple by creating a cube of 1 unit scale. First of all, we create a new game object and we add to it a mesh filter component and a mesh renderer component. With the mesh renderer, we add a material to render our shape. On the mesh filter component, instead, we need to access the mesh data and populate the vertices with an array of vector 3 and the triangles with an array of integers. Let's populate our array of vertices. The vector 3 data we put in represent the spatial position of a single vertex. Remember that the order in which we insert them inside the array is important. So let's visualize what we are gonna do. We number each vertex starting from 0 to 7. The number 0 will be the front bottom left vertex. Let's assume we want to position it at the world origin, so our vertex 0 is identified by position 0, 0, 0. Since the width of our cube is 1, vertex 1 will be at 1, 0, 0. Vertex 2 will be at 1, 1, 0. Vertex 3 at 0, 1, 0, and so on. Now we have the position of 8 vertices. We need to assign them to the mesh. At the moment, our vertices are just invisible points in the scene. We need to connect them and form triangles in order to render them. And it's now crucial the order in which we have stored their position in our vertex array. In fact, the triangles array identifies them through their array index number. Be wise and help yourself with sketches when working with visual things like that. You can think of the face of our cube as the union of two triangles. So, for example, our front face is composed of the triangle 0, 2, 1 and 0, 3, 2. We do the same for all the other cube's faces and we assign the final int array to the mesh triangles property. If we now play our scene and look at the origin, we can see our fabulous cube. Who is used to 3D concepts is probably wondering, how does the mesh know which is the rendering side of all our triangles? Luck, of course not. Inserting the integers in the triangles array also specifies the normals of the triangles. Normals are vectors that determine which way a triangle is facing in order to render it and understand how light bounces off of it. If you want your normal point outward and so be forward facing like in our case, specify your vertex inside the triangle array in a clockwise direction. So basically put 0, 2, 1 and not 0, 1, 2. Now we know the basics. How do we make it infinite? Simple, we don't draw a full mesh in a single frame and, instead, we extend a shape over time, following the player. Inside an update cycle, we call a function called monoline. We add a time check so that we regulate at which rate to call it. For performance reasons, it's important to avoid drawing each frame. Inside the function, if it's the first time we enter, we create our game object, its components and its mesh data. We also add a mesh collider to detect collisions. Remember to update the collider's mesh property each time you change the mesh, or it will not update properly. You can notice that the vertices positions are now led by the player's position. We don't position them manually in a single location, as we did with the example cube. And we draw only the front face of our barrier. We also initialize an int variable called x to 4. This is the number of the vertex from which we will start drawing in the next cycle. And we set a boolean value called isEven to false. We'll use it to understand what face to draw. In the next cycle, first time is false, and we'll not do it anymore. We jump to the if isEven clause. The difference between isEven true or false identifies where to start drawing our vertices. When isEven is true, we start from the bottom left corner, when it's false, from the upper left corner. In each update frame, we just draw the top, left and right faces. We don't need the bottom face since our camera never moves under the player. Neither the back face since it's covered by the others and we don't see it. Depending on the isEven boolean, we have therefore two ways of drawing the faces. And since what changes from one frame to another is only the vertices we want to connect, we parameterize the formula with the x value and voila! Now that the infinite mode works, we can implement another one, taking advantage of the cube example. We add a gap mode to the game. The only difference is that at a rate we decide, we spawn a new entire game object. We parameterize the length of the cube so that we can decide it in play mode. Nice! The core mechanic of the game is ready. GG. Project over. And it would if we don't mind all the multiplayer stuff, the game logic, handling the rounds and the game phases, creating the main menu and the lobby, etc, etc, etc. Let's now see some gameplays. Here are some matches with our friends. The next step to increase rage quits is adding a button for sprinting, so that you can overtake your opponents. And we want to change the view mode to landscape instead of portrait, so that there is more view angle and space for the buttons. Also, we want to thank our friend and colleague Matteo Balasso for making this awesome soundtrack for the game. We really wanted something strong and rude, and this fits perfectly. Matteo is a great musician and sound designer. Check his works out, links in bio. So, my friends, we are at the end of the video. What do you think of this project? Would you play a game like that? Or would you add some different features to it to make it more fun? Please let us know in the comment below. Follow us on our socials and be ready since we are starting our indie game project. We will tell you more later. Thanks for watching. Bye!